Click the bell icon to get latest videos from Ekeeda.
Hello friends, now we are going to see the design of synchronous decade counter using T flip-flop. Let's start the discussion. So, your heading is Design of Decade Synchronous Counter using T flip-flop. So, first of all, you have to decide how many flip-flops you are going to use. So, decide number of flip-flop. So, given flip-flop is of what? T flip-flop. Now, what is mean by decade counter? Decade counter is called as what? When a counter counts from 0 to 9, then it is called as the decade counter. So, for decade counter, it should start with 0 and it should end with the 9. So, we will draw the state diagram for the decade counter. This is 0, 0, 0. We have to draw for decade counter. So 0, 0, 0 and one more 0 is required. This is your QD, QC, QB and QA. So you have to start from 0, 1, this is 2, 3, this is your 4, 5, 6, 7, 8 and this is your 9. So in this way you have to draw the state diagram. This is your state 1, S1, S2, S3, S4, S5, S6, S7, S8, S9 and S10. Now these are the arrows for the present state and the next state. So you have to mention here. So this is the diagram for the decade counter. It will count from 0 to 9 and the next state for the 9 is again 0. Now we will draw, third step is to draw excitation table for T flip-flop. We are going to draw the excitation table. So Qn plus 1 and T flip-flop we are going to use. So 2 inputs means how many combinations? 0, 0, 0, 1, 1, 0, 1, 1 and the output 0, 1, 1, 0 is for the T flip-flop. Now decide the number of flip-flop. So if you see that state diagram, we will use here 4 number of T flip-flops to design the decade counter. Now after drawing the excitation table for the T flip-flop, so the next step after excitation table, we have to draw the circuit excitation table. After drawing the circuit excitation table, you have to draw the K-map for the table. And after drawing the K-map, you have to design the logical diagram. So let's start with the circuit excitation table. So we will start with the circuit excitation table. The excitation table for the T flip-flop is what? For 0, 0, 0, 1, 1, 0 and 1, 1. We have 0, 1, 1, 0. This is for T. This is for Qn and Qn plus 1. You have to use this table for designing the circuit excitation table. So now we will start with QD, QC, QB, QA. These are the present state. Then we have QD star, QC star, QB star and QA star. After that we have TD, TC, TB and TA. So these four are the present state. These four are next state. And these are the input to flip-flops, specifically T flip-flop. So now present states are what? We will start with 0. So 0, 0, 0, 0. 4 bits are there, so 0 to 15 you have to write. And with the use of 0 to 15 you have to design the decade counter. Let's see how to design. Then 0, 0, 0, 1, 0, 0, 1, 0 for 2. This is for 3, 4, 5, 6, 7, 8, 9. This is for 10, 11, 12, 13, 14 and last is the 15. Now we have to design decade counter, means it will start from 0 to 9. Now for 10, 11, 12, 13, 14 and 15 next states will be 0. So we will design accordingly. For 0, 0, 0, 0 next state is 0, 0, 0, 1. For this 0, 0, 1, 0. Then 0, 0, 1, 1, that is 3. Then we have 4 is the next state. Then 5, 6, 7, 8, 9 and for 9 again we have 0, 0, 0, 0. And for all the remaining states, the next state will be again 0, 0, 0, 0. In this way you have to design the table for the next state. After that we will focus on the T flip-flop. For that you have to refer the excitation table for the T flip-flop. So let's start the output for, so you have to take QD star. So 0, 0 is 0, again 0, 0, 0, 0, 0, 0, 0, again here 0, 0, we get 0, 0, 1, we have 1, 1, 1 is also 0. After that 1, 0 is 1, 1, 0 is 1, here also 1, 1, 1, 1 and 1. Now we will focus on TC. So you have to compare QC with QC star. So 0, 0, 0, 0, 0, again 0, 0, 0, 0, 0, 1, 1, 1, 1, 0. Again we have 1, 1 0 1 1 0 1 0 1. Now for 0 0 we will write 0, again 0 0 we will write 0, 0 0 we will write 0. This is again 0. Now 1 0 1 1 0 1 1 0 1 and 1 0 again 1. Now we will write for TB. You have to compare 0 0 0 1 is 1, 1 1 is 0, 1 0 is 1, 0 0 is 0, 0 1 is 1, 1 1 is 0. After that you have 1 0 1 0 0 0, then 0 0 again 0, 1 0 1 1 0 1 0 0 0, again you have 0 0, we have to write 0, then 1 0 1 and again 1 0 1. In this way you have to complete the table for the TB. So now we will focus on the TA. For TA you have to focus on QA and QA star. So 0 1 is 1, 1 0 again 1, 0 1 1, 1 0 we have to write 1, again we have 1 0 is 1, 0 1 is 1, 1 0 is 1, 0 1 is 1, again we have 1 0 1, 0 0 we have to write here 0, then QA is 1, QA star 0, so 1, 0 0 is 0, 1 0 is 1, 0 0 is 0 and 1 0 is 1. In this way you have to complete the table for the TA. Now we will focus on the K-map design. So let's start with the K-map design. First of all we will design the K-map for TD. So how many inputs are there? For the K-map you have to focus on TD table. 16 entries you have to do. So 4 variable K-map we required. So we will start with the K-map for TD. We have to draw here 4 variable K-map. We can write here QD, QC, QB and QA. You have to write here 0 0 0 1 1 1 1 0. After that 0 0 0 1 1 1 1 0. Then inside the boxes you have to write 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Now after labeling all the boxes you have to do the entries for TD inside the box. So we will write only ones and we will ignore zeros. So we will get the SOP expressions for the TD. Now let's start the entries. This is for 0 1 2 3 4 5 6 and 7. For 7 it is 1, then 8 and 9 onwards it is 1. So we will write here 9 10 11 12 13 14 and 15. So in this way you have to write the ones. Now we will focus on the grouping. So let's start the grouping for number of ones. You have to search for 8 number of ones. So we don't have here 8 number of ones. We can't make a group. Here we have 4 number of ones. So we can take a group of this 4 number of ones. So let's start the grouping for TD. We can make here first group, that is for this ones, 4 number of ones. The equation we can write here is of what? QD, QC. Now we can take this 4 number of ones. The equation for this group is what? Same is what? QD, and here QA. After that we have to take a group of this number of ones, 4, and the equation for this is what? For these two we have QD is same and here QB is same. After that only 1 is remaining, so we will take a group of 2 ones, and the equation for this is what? For these two we have QC is same, and for this one QB and QA. So in this way you have to make the groups for TD, and finally you have to write the expression for the TD. So now we will write the final expression for the TD. So for TD we have QA QD plus QB QD plus QA QB QC plus QC into QD. This is for only TD. After that we will draw the K map for TC. So we will draw 4 variable K map here. In this way you have to draw the K map. Variables are QD, QC, QB and QA. After that you have to write here 0 0 0 1 1 1 1 0. Then again 0 0 0 1 1 1 1 0 you have to write here. After that inside the boxes you will write 0 1 2 3 4 5 6 7 8 9 10 11, then 12 13 14 and finally 15 you have to write inside the boxes. Now we will focus on the outputs of TC. So we will start with, we will not consider 0, we will start with only ones. So we will write here 0 1 2 3 4, we will not consider. For TC 0 1 2 3 4 5 6, then for 7 8 9 10 11 12 13 14 15. So for 12 13 14 and 15 we will write here only ones. In this way you have to make an entry of 1 inside the boxes. Now K-map grouping starts. So if you see here we have to make a group of these 4 ones, and the equation for this is what? QC into QD. And finally we can make a group over for these 2. So we can write here QD bar for this one and here QA QB. In this way you have to write the equations for the TC. So we have the K-map for TC. The final equation for the TC we can write here as QC QD plus QA QB and QD bar. So we have got the equation for TC. Next we will move forward to what? TB. So K-map for TB. We will draw here the K-map. This is a 4 variable K-map. Here 4 variables are what? QD, QC, QB and QA. We will write here 0 0 0 1 1 1 1 0. Here also 0 0 0 1 1 1 1 0. After that you have to draw here what inside the boxes, labeling 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 and finally 15 you have to write. After that you have to make entries for TB inside the boxes. So we will focus on only ones. We will ignore 0. So 0 1, for 1 it is 1, 2 3 4 5 6 7 8 9 10 11 12 13 and for 14 15. In this way you have to make entries of logic ones. After that grouping starts. Now how to make a groups? So if you see here we can make a group of 4 ones. So this will make a first group of 4 ones, and the equation for this is what? QD is same, here QB is same, and for this ones we can make a group of 4 ones, and here the equation we can write is what? QD bar dot, here QA is same, QB is changing. So finally we can write here what? TB equals to QD QB plus QA QD bar. In this way you have to write the K-map equation for the TB. Now we will move forward for the TA. So for TA we will again draw 4 variable K-map. Here we will draw the K-map for TA. 4 variables are what? QD, QC, QB and QA. We will write here 0 0 0 1 1 1 1 0. Here also 0 0 0 1 1 1 1 0. Inside the boxes we will write 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 and finally 15 you have to write. After that you have to make entries of logic 1 inside the boxes. So we will make entries of logic 1 and we will ignore logic 0. So let's start with 0 1 2 3 4 5 6 7 8 and 9. Up to 9 you have to write logic 1. So we will start with what? Entering logic 1. So 0 for 1, again 1 2 3 4 5 6 7 8 and 9. We will again cross check 0 1 2 3 4 5 6 7 8 and 9. For 10 it is 0, then for 11, then 12 is 0, 13, after that 14 is 0 and finally 15. So in this way you have to make the entries of logic ones. Now we will focus on grouping of ones. Let's start the process of grouping. So we will make a group of these 8 ones, and the equation for this is what? Only QA. After that we have the group of these 8 ones, and the equation for this is what? QD bar, because 0 is same and QC is changing. After that we have only this one is left, Here also we can make a group of these 4 ones, these 2 ones, and these last 2 ones. And the equation for this is what? QC bar 0 is same, and here QB bar. So in this way you have to make the grouping. So finally we can write the equation as TA equals to QA plus QD bar plus QC bar QB bar. This is all about the K-map for TD, TC, TB and TA. Now we will move forward to the logical diagram. So we have all these 4 equations. Now we will design the logical diagram with the use of T flip-flops. So we will draw here 4 T flip-flops. We will start with, this is your first flip-flop, TA. Output is QA bar. After that we have next flip-flop. This is your TB QB bar. Then we have TC, here QC bar. After that we have TD, here QD and QD bar. Now we will apply synchronous clock to all the flip-flops. This is the symbol for the clock. We have to make here synchronous clock, means take the common clock outside. In this way you have to apply the synchronous clock because it is a synchronous circuit. After that you have to just mention here all the terminals. This is your T flip-flop, first T flip-flop is 2, T flip-flop 3 and T flip-flop 4. Now separately I am going to draw with the logic gates for TD, TC, TB and TA. This you have to apply to each terminals TA, TB, TC and TD. Now after that I will draw the logic diagram for TD. So we require here 1, 2, 3, 4 AND gates we require here. So we will write here, this is your first AND gate, this is your second AND gate, third AND gate and this is your fourth AND gate. Input to the AND gates are what? QA, QD. Next is what? QB, QD. After that we have QA, QB and QC. Then we have QC, QD. We have to take the sum of all the outputs of AND gate. So we will use here OR gate because we have to take the logical sum. So with the use of OR gate you will get the output for TD. This logical diagram you have to apply for the TD. Now we will draw the diagram for TC. For that we require 2 AND gates. So we will draw here 2 AND gate for logical multiplication. The input to the first AND gate is what? QC. This is your QD. After that we will draw QA, QB, QD bar, and then you have to do the logical sum. For that you will draw here logical OR gate to get the output for TC. Now we will focus on what TB. The logical diagram for the TB again consists of two AND gate. So we will draw here two AND gate. Input to this is what? QD, QB. Here what? QA, QD bar. After that we will draw OR gate for logical sum, and this becomes the output for what? TB. You have to apply this TB over here. Now we will focus on what? TA. So only one AND gate is required. So we will draw here one AND gate. Input to this is what? QC bar, QB bar. Now we want to do logical addition. So we will draw here what? Next input is QA, and after that we have next input is QD bar. Logical addition you have to perform, and here you will get the output as what? TA. So in this way you can draw the logical diagrams for TD, TC, TB and TA. This is figure for TA. This is your AND gate and this is your OR gate. This is figure for TB. This is your which logical gate? And this becomes your OR. Figure for TC. This is your again logical AND gate, and this becomes your logical OR gate, and this gives you figure for TD. All these are the AND gates you can mention here, and this becomes your logical OR gate. And this is the synchronous clock for TA, TB, TC and TD. In this way you can design the decade synchronous counter using T flip-flop. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.